Geometric series. This is just the summation of your geometric sequence. So you're still actually adding here just because it's geometric. Now getting from term to term, you multiply, right? So in a geometric, to go from one term to the next, you're multiplying. But when it asks for the series, it wants the summation of the terms. So you still want the summation of the terms. For this particular one, you need the first term and you need your common ratio and how many terms you're adding up. You do not need your last term for a geometric for this one. So it's a sub 1 times the quantity 1 minus r to the n over 1 minus r. Over 1 minus r. So this is one you probably just want to memorize so that you have it in your brain. All right, so let's look at this in use. Use the formula to evaluate these. All right, so we have this formula here. Nope, I don't want to. There, I just want to move it. All right, so this is the formula we're using. They want us to evaluate. When you see the word evaluate, it just means add it up. Give me a total. So if I want to evaluate this, how many terms do I have? 6. So summation of those 6. My first term, that's going to be 3. 1 minus, what is my r? How am I getting from term to term? Multiplying by 2. So my r is 2 to the n. What was my number of terms? 6. All over 1 minus my r, which was 2. So that's all you do to evaluate this, by the way. 2 to the 6, what is that guy?
That's
64, right? So 1 minus 64 is negative 63, right? So we're going to do on top, negative 189. On bottom, we have 1 minus 2. There we go. My summation here is 189. Let's look at this on a word problem, then we'll look at infinite series very quickly. The Floyd family starts saving for vacation in August. They expect the vacation to cost $1,375. They start with $125. Each month they plan to deposit 20% more than the previous month. Will they have enough money for their trip? How many months do they have? Does it say?
No. It's March. Yeah, in March.
It's March.
Right there.
Yeah, and so n is 6, right? What's the ratio? What are they multiplying by each month? 20%. So what are they multiplying by? 1.2. So my R here then is 1.2. All right. What's their initial amount?
125.
All right. So we want to say in 6 months, will they have enough for their trip? So what are we going to do? We're going to say a sub 1 minus r to the 6th power, right? All over. And I think when they get all this out, you end up with this guy right here. Y'all know how to put it in a calculator. Do they save enough money?
No.
They do not. They need to save more than 20%. At this point, we've said there are 5 terms in it. They had 6 months to save. That is a finite number of terms, right? You can also have infinite series. See this little ellipsis right here? The other way it can indicate that it's an infinite series is this little guy at the top of it, meaning it goes on infinitely, right? And so you start having to decide whether or not in the terms are converges or diverges, okay? Converges, when your ratio is less than 1, it means they're getting smaller, right? It is said to converge. It's getting closer and closer to a number. If your R is greater than or equal to 1, which if it's just equal to 1, it's staying the same. But if it's greater than 1, it's going to diverge, meaning it is not going to approach a specific number. It's just going to keep getting infinitely larger, okay? Or smaller if it happens to be negative. We are talking about absolute value. So you'll notice it's absolute value of R. So the first thing they just want us to do is say, does this converge or diverge? So you just have to figure out what your R is. What is your R here? What is my R? Negative 1/3. So then Our absolute value is positive 1/3. So does this converge or diverge? Converge. That's how simple this is. That's all we're asking. Converges, diverges. What about this guy? What's my R here? What's my R in this geometric series? When it's in explicit form, it's handed to you, right? My R is 2. Converges or diverges? Diverge. There we go. That's all you need to know for this example. Does it converge or diverge? The reason you want to know this is because if it converges, you can figure out what the sum is going to be. If it diverges, you cannot. Okay, so go to page 616. The sum of an infinite geometric series. So the first formula was the sum of a finite series. You had to know your number of terms. For an infinite series, you can calculate it if it converges. So if your R is less than 1, you can calculate what the summation is going to be with this formula. All you need is your first term and your R. That's it. Your first term over your 1 minus R. R being the common ratio. So look at this example. The length of the outside shell of a closed chamber of a nautilus is 0.9 times the length of the larger chamber next to it. Estimate the total length of the outside shell for the enclosed chambers. All right. My first term, they give it to me, is 27. So we're going to start with that 27. So ace of 1 is 27. What is my R here? If it is 90% of it, it's getting smaller. So that means it converges. And it is 0.9. 0.9. So if I want to calculate this, I literally just have to take my first term over 1 minus my R. And I'm going to get this. That's the summation for that. That's the summation. All right.